Projection of lines. In this video, we will discuss how to draw the projection of lines. Now let us consider a line. Let's name the two endpoints as A, B. Let us see the possibilities of a line in the first quadrant. The line may exist in four basic orientations. These are the line parallel to one plane and perpendicular to the other, the line is parallel to both planes, the line parallel to one plane and inclined to the other, the line inclined to both planes. Now let us see each individual orientation of the line in detail. Consider the first orientation, the line parallel to one plane and perpendicular to another. In this orientation we have two possibilities. These are the line parallel to HP and perpendicular to VP, the line parallel to VP and perpendicular to HP. Let's solve a problem in the first case so that we understand the concept better. The line parallel to HP and perpendicular to VP. A 50 mm long line AB has its end B at a distance of 15 mm in front of the VP. The line is perpendicular to VP and 30 mm above HP. Draw the projection of the line. The front view projected on VP looks like a simple dot and the top view of the line is displayed as it is on the HP. We already know the naming. Front view gets dashed lowercase letters and the top view gets lowercase letters without dashes. Let's represent them on a drawing sheet. First, draw a reference line XY, say 100 mm. Top view gives the true shape of the line. So let's start with the top view. Draw the top view of the AB line below the reference line with length 50 mm at a distance of 15 mm from XY line. It is the true length and first end is B from the VP and other end is A. Next, draw the front view of the AB line above the reference line at a distance of 30 mm height from the reference line. It just looks like a dot and name it as A-B- as both ends coincide. For this orientation, the side view is not mandatory. Let's solve problem on second case, the line parallel to VP and perpendicular to HP. A 60 mm long line AB has its end B at a distance of 20 mm above HP. The line is perpendicular to HP and 40 mm in front of the VP. Draw its projections. The top view projected on HP looks like a simple dot and the front view of the line is displayed as it is on the VP. Let's draw a XY line, say 100 mm. The front view gives the true shape of the line, so let's start with the front view. Now draw the front view of the AB line with length 60 mm above the reference line with 20 mm height. It is the true length and name the first end as B- and the second end as A- from HP. Next, draw the top view of the AB line below the reference line with 40 mm distance from the XY line. It is just a dot and name it as AB as the two ends coincide. For this orientation also, the side view is not mandatory. Line is parallel to both planes. Now let us see the procedure for the line parallel to both planes. Let us imagine a line that could be parallel to both planes. This means it is not perpendicular to any principal plane and it is perpendicular to the profile plane. Let's draw the reference line XY, let's say 100 mm. Now we will draw the views for this line. For every case, first we will draw the true length, that means the view which gives the complete length without reduction. The reduction occurs in the length of the line due to its inclination. In our case, the line is not inclined to any plane. We can draw any view. First, draw the front view of the line as per given dimensions above the reference line and name it with lowercase letters with dashes. Then, draw the top view below the reference line, that is below the front view, and name it with lowercase letters without dashes. Now let's look into the side view. Here the line just looks like a point from the side view. So let's draw the side view of the line, the point, beside the front view. Take x1y1 line which is perpendicular to the xy line. Consider the line of intersection of xy and x1y1 as C. From the top view, extend the line until it touches the x1y1 line and name it as P. Now take a compass and C as center, P as the distance, draw an arc until it touches the xy line. From there, draw a vertical line upwards and extend the line from the front view to the right side. These will intersect at a point. It is our required side view. And name this point with lowercase letters with double dashes as A double dash B double dash. We have now seen a procedure to draw projections of a line parallel to both planes. Now let us take measurements and do a real problem. A 50 mm long line AB is parallel to both HP and VP. The line is 25 mm in front of VP and 60 mm above HP. Draw the projection of the lines. Let us discuss now the steps for drawing the orthographic projection for the given problem. First, collect the given data from the problem, that is, the given line AB and its length 50 mm. It is parallel to both HP and VP. The line in front of VP 25 mm, the line above HP 60 mm. Let's draw an XY axis line, say 100 mm. And as we know that the above problem is line parallel to VP and HP, here we can get the true length of the line by seeing in the front view and top view. Now draw the front view of the AB line with length 50 mm above the reference line with 60 mm height as true length and name the first end A dash and second end as B dash. Now draw the top view of the AB line below the reference line with length 50 mm with 25 mm distance from XY line and name the first end as A and second end as B. For the side view, take x1y1 line which is perpendicular to the xy line. Consider the line of intersection of xy and x1y1 as C. From the top view, extend the light line until it touches the x1y1 line and name it as P. Now take the compass and C as center, P as the distance, draw an arc until it touches the xy line. From there, draw a vertical line upwards and extend the line from the front view to the right side. These will intersect at a point, which is our required side view. And then name this point with lowercase letters with double dashes, A double dash and B double dash.